So data science is kind of interdisciplinary field. So we have to learn different knowledge to form the foundation. As you can see in the center here, it's called data mining. It's a knowledge discovery. So data mining, the purpose of data mining is knowledge discovery. Discover knowledge, okay, so in the center. So we also require some statistic idea. Because, for example, we will talk about regression, right? Regression is very best one in statistics. So it's kind of knowledge we need to learn statistics, and also some idea about artificial intelligence. But most of people nowadays have some experience with the AI, ChatGPT, Perplexity, Gemini, and so on and so forth, right? And we also need to acquire some idea from management and science, or even information system. So that's why we will talk about the ERP, the customer relationship management, okay, and even BI, so on and so forth. That's very interesting, right? So knowledge. We do not mine dirt to find dirt. Sometimes it's called garbage in, garbage out. It's okay. So we have to make sure the data is good. So we have to clean data, transform data. Then we can select a appropriate model. And then we try to build a model and use model to predict something. Okay, so you can see the definition here. Non-trivial process. Non-trivial process. I guess it's a new vocabulary for you, right? What is non-trivial? Non-trivial process of identifying valid, novel, potential, useful, and understandable patterns. Okay, pattern in the data. So, non-trivial process. So what is non-trivial? There's a lot of process, when we talk about data. We rename the column name is a process. We compute the average value of a column or variable. It's also a process. Right? So there's a different type of process. But what is a non-trivial process? We will say it's not non-trivial. It's non-trivial. Trivial means very small piece. Very small piece. Not big deal. Non-trivial is a big deal, especially for knowledge discovery. Right? It helps us to discover the new knowledge that we can get from the data. Right? Okay. So from data to insight, there's a lot of time we saw the word called insight all the time. Insight. To be more specific, it's kind of pattern or structure that exists in the data. It's waiting for you to find out, to discover. Okay. So there's a called hunch and to actionable intelligence. On the left side, you can see that there's a raw data. Usually, there's a bunch of data, so big. Yeah, there's a lot of information here, and we try to organize too much information. Try to organize so that we can have actionable insight or intelligence that we can use. So data mining is a non-trivial extraction of implicit. I'll have to use this word. You see that? Data mining, the non-trivial extraction of implicit, previously unknown, and potentially useful information from data. I would like to ask what is implicit? What does implicit information? What is implicit information? Sometimes people call implicit knowledge. What is implicit knowledge? Implicit information? When I say it's implicit, it means it's not so obvious. It's hidden. It's hidden. It's kind of like black box. You cannot see it, so you have to unbox it. Okay, so we can have unboxing or extract. So extract, we call extraction. To get the data, to extract, to only catch the key idea and skip rest of them, only get the key idea that you need. Okay. The key idea is the pattern again, or you can call it insight. That's fine. We had also talked about these ideas before. I don't know how much do you remember about the categorization of data mining. It's a taxonomy of data mining. Also a new keyword again. Taxonomy. Right? Taxonomy. Taxonomy is a category. Okay? Different type is category. Taxonomy. Taxonomy of data mining. Alisa, how many types do we have of the data mining based on the slide here? 3. Can you name it? Prediction, association, and okay, that's good. Clustering. Okay. So prediction of what? Predict what? You want to predict something, but predict what? Based on the slide? Not sure. Of course, at the very beginning, I will say, I'll tell you that in BI we have 3: business, analytics, right? Analytics. But we have 3 types: 1, 2, 3. In the middle is called predictive analytics. But the question is, we predict what?
Predict the business pattern. I mean, when we want to, for example, when we want to predict customer churn, maybe we need to analyze the pattern first.
Okay, good. Alisa, how about you?
Predict the
Trend? How about I say predict y hat? Do you know what is y hat?
The outcome.
Huh? The outcome? Yeah? It's true outcome or this one and this one is different. Right? This one is your actual, right? Actual outcome, but this one is estimated outcome. So this predicted is predict this one. Okay. How close the predicted of the estimate outcome is so close to the actual outcome? How close? Okay. That's one way predicted. Predict number. You see that? Predict number. We can use regression. Regression to predict the estimate outcome. And then another one is called predict labels. Or sometimes we call it predict classes. Male is a class. Female also is a class. Okay? Smoke is class. Non-smoke is another class. It's not a number, but it's a class. So the second type. So predict two types. Predict number, regression. Predict labels, classification. Okay, got it? So it's all about predict. Predict belong to the supervised learning. Supervised learning. Supervised learning. We have already talked about supervised and unsupervised learning in previous course, but I'm not pretty sure. Do you still remember? Supervised learning. Do you still remember? A little bit, good. I'm not a little bit. Why is a little bit?
I remember a little bit about supervised learning and unsupervised learning. But I remember that supervised learning actually that we can train the machine learning, and they usually learn based on the input that we give to them.
Mm-hmm.
I mean, they can learn by the rule that we give to them. So
Learn by the rule
yes,
we give to them.
the rule or the input.
The input could be a lot of things. Right?
Yes, I forget how to say it.
Right? That's right. Just try it. Just try it.
Like for example, like the regression and the analysis, that we have the exact formula how to do that, right? So the machine learning can
Okay.
yeah, I think
But it's good. You try to express the idea about the supervised. Hazel, do you have any idea?
Supervisor
Supervised, yeah.
is like the machine learning, and you use the model with the and train the model to give the label data. It's like for the email, it's like spam or not spam, and put the data and also the correct answer. But unsupervised learning, you cannot put the correct data. You just try to discover the pattern of the data.
Okay, that's good. That's good. Thank you. Liz, do you have other comments? Totally agree with Hazel.
I agree with her, and I want to add something like
Okay.
the supervisor, like we have the specific one, the specific one.
Specific one. Mhm.
But for the unsupervised, it's like we want the machine learning to like learn by themselves.
Learning by themselves. Oh, I like it. Sophie, after their explanation, how do you explain supervised learning?
I have no idea.
Still have no idea? Okay. Still have no idea? Okay, let me make a very simple example here. Let's take an image, an example. Because, for example, here, on my head, I have marker, right? This one. I just tell you it's marker. But I didn't say, I just show you the object. It's only an object. Okay. Supervised, I have to let you know. I have give you a label. Marker, this one. Marker, this one. So bundle together them as an input to the model. It's called supervised. I let you know it's called marker. But for unsupervised, I will not tell you this is what. I just give you the object. And you have to try to learn that yourself or by the program. Then you will come up some rule or pattern or structure. Got it? So clear? Easy to understand? Okay, so let's review the category of data mining methods called we have supervised and unsupervised learning. Supervised learning with label, data with label, or with class. But unsupervised only data, no label, no class. Okay. So supervised learning we predict value, regression, predict class or label, classification, right? And for unsupervised we have association, clustering. Okay, let's again. What is clustering? Clustering. You can understand clustering by grouping. Okay. Okay? By grouping object. You can group animals. You can group people. Okay? So it's a grouping or segmentation. Just like we do in marketing. Do the segmentation. It's a consumer segment. It's a corporate or business segment. Something like that, right? How about the association? How about association?
Relation.
Relation? Okay, good. Relation and relation of what? Relation of what? Yes? Similarity. Quite close. Quite close. The similarity of relation will quite close. It's called close to the clustering.
Yeah.
Right? They are so similar. Right? So called cluster or segment. They are all consumer. They are all corporate. Right? But association is something else. Association of
Relationship.
yeah, relationship of what?
Between the variables or
Variable.
or the
I
data.
would like to be more specific. Among items. Among items you purchase, especially when you went to the market, supermarket, sometimes you will buy something altogether.
Yes.
If you buy milk, you usually buy bread, right? So bundle the bread with the milk. So it's kind of associated. They link together. So you can see it's called link. They linked as an item set, right? So you have to say item set. So now you have the idea. Unsupervised clustering and association. Association for this one is kind of relationship among the item set. I would say the clustering is so practical. Clustering is so practical. Association is also very practical. You know the Walmart. You see that it's a big wholesale. It's called Walmart. But Walmart in USA.
Yeah.
Right? The very famous classical case about the association is the case of what? Have you ever heard of that? Walmart, a very classical association case. Two items bundled together for sales. Oh.
Beer and
Beer.
diapers?
Ah, good, excellent. Diapers and beer.
Yes, diapers and beers.
Diaper and beer. Wife usually ask husband to buy diaper, and the husband like to buy beer. They like to watch a football game with their friends, so have the beer and the diaper for the children. So bundle together, bundle sales. Okay. This is just a review, right? In the first section, we already go through the process called CRISP-DM, cross-industry standard process for data mining. 6 steps. Understand business, understand data, and data preparation or data cleaning, data transformation, and model building, testing, evaluation of model, and deployment. Okay, but usually, people always like to learn model, but for data transformation in the real world, the translation really matters. It's a big pain problem. Usually take time of 80%, 70% to 80% of your time. Collect data, clean data, get data ready. Spend a lot of time, but build a model, maybe 20% of your time. Okay. So just like we show here, we consolidating, collect all the data, relate data together, and clean data, handle missing value, transform, or even normalize it. Do I have mentioned the normalize before? The third step. Transformation, normalize. Transformation covers different kind of tests. But one test is called normalize. But what is normalize?
I think it's when we make sure that there is no outliers in our data set after the data preparation.
Okay, that's good. That's a good idea. We want to do the outlier detection.
Yes, and also from that we can know that the data distributed normally.
Okay.
Yes.
Okay, that's good. Hazel, can you explain that again about normalized data? There's transformation, normalized data.
For me, the normalized data is the data has been dispelled and or transformed to the standard range, usually to make it easier for model to process.
Oh, okay. This, how about you? Normalize.
something
Not that easy,
because
right?
I don't really have idea about this one.
Okay, let's say we have transaction. Let's say we have transaction, we have something, we have item, right? And we have sales, the selling price, right? Selling price. And we have quantity, right? QTY, quantity, right? So different column, and of course we have other column. I will ask the unit of selling price and unit of sale of the quantity is the same or not? The unit of selling price and unit of the quantity is the same or not?
No.
No, right?
No,
This one is for dollar sign. It's pieces, right? Different, right? So how can we just put the different scale together into a model? So maybe we can do the normalize to remove the unit. Okay. We have another method called standardization. Standardization. Also to remove the unit, okay, by this is your original value minus your mean value. I'll say that, your mean value. And divided by the standard deviation, or SD for short. That's the calculation. You don't have to memorize the formula because the software already can do it for you. You just have to get back the idea. Do the standardization to remove the unit. Okay? Remove the unit. Remove the unit. Okay? Good. It's called transformation or normalize, and then maybe we have too much variables. And that's called reduction. Alisa, what does reduction mean?
Like you reduce the data that you don't want to focus on.
You reduce the data. Data is, could be has a different meaning. Can you be more specific about the data? We want to reduce or reduction.
I think data reduction is when we reduce the data dimension to avoid overlap.
Wow, excellent. Excellent. Reduction. Reduction of features. Okay. Next, for data mining, we have this called terminology called features. But in applies the statistic, we call independent variable. Okay, not include dependent variable. It's called independent variable. Okay, and in data mining, we call features. Sophie, what is independent variable?
Variables that don't depend on nothing.
Depend nothing? Yes. But the independent means the variable will influence other variable. The variable that will influence the dependent variable. Or sometimes we have many x. Okay, many x. And this is y. Okay. And in data mining, we have many x. And we have y. And how do we call this one in data mining? We do not call it dependent variable. We call it what? What? 3, we call it what? We call it what? In orange 3, we call it what? We call what? We call X feature, and we call Y what? No idea.
Target.
What? Okay?
Target.
Target. Excellent.
Oh.
Excellent. Target. Yes, that's right. Excellent. Okay? Call target. Okay. So reduction, it means reduce the features, the number of features or number of independent variable. Okay. Because what? Because there's some overlap. The X, sometimes there's overlap among the X. For example, the X1 and X2, they have very high overlap. The overlap maybe in terms of correlation. We can just have a specific number, 0.97, 0.97. The two values so close together. So we don't need to use 2x. We can just get rid of one, only keep 1. So it's kind of overlap, too much overlap. So we can reduce the number of independent variables or reduce number of features. That's called reduction. Okay. Now, next, I would like to let you have a discussion. Let me know, because we like to build a predict model, a special predict label, not predict class. I will say it again. We have two kinds of prediction. We predict number and predict label. In this case, I would like to discuss. We like to predict labels. Predict label. Could be the possible retarget. Okay, I see target in orange 3. Yes? No. Label yes, label no. So how can I evaluate the performance of predict model? So since we all with lots of class I didn't join class. So we have only 6, maybe we just temporary group. One group, second group, the third group. I would like you to discuss. Once you have a predict model, how will you evaluate how good the model is? Predict label. Yes or no? Male, female, smoking, not smoking. Okay, this label. So I would like you to give a few minutes to discuss with your group mates, and then let me know.